Unit 1 Chemistry, Chapter 4, Part 2. So looking at how we represent ionic compounds first. There's a couple of different ways we can represent them. We can draw out the lattice, if you really feel like it. That doesn't actually give us the most useful information though. It's a good model to explain the properties, yes, but in terms of showing individual combinations, it's not that useful. To show how ionic compounds are made, we would draw electron transfer diagrams, sometimes called dot and cross diagrams, because we have dots and crosses on them. So, first thing we say, because only the outer shell are involved in making an ionic bond, we are only going to show the outer shell electrons. We call it dot and cross because we're going to use a cross for the electrons of one and a dot for the electrons of the other element. Okay? Doesn't matter whether the cross is for the anion or the cation, it's just to show the difference between them. Okay. Now, in this case, sodium is giving up its electron and giving it to chloride, and that's going to leave this one with nothing in that shell, so it's going to go into the next shell, which is full and therefore stable, and give chlorine a full outer shell as well. So we do an arrow to show where the electron goes from and where it goes to. When it gets to its new position, we're going to keep that same cross symbol that we were using before, because that's showing that it had 7 of its own original electrons plus an extra. And we're going to add a charge to show the ions that are formed. Okay, so you're going to be doing it on paper, not on a PowerPoint, so you don't get to get things coming in and going out. So this is how we show it in full. You would draw out the outer shell with their electrons. You do an arrow for each electron that we're moving. In this case it's magnesium, so it's giving up 2, and they're both going to oxygen. We then do an arrow, because it's like an equation, and we show the magnesium with nothing left in that outer shell. Yes, I know it's now got a new outer shell, but you don't need to go drawing all of that. And its charge of 2+, and oxygen with its 6 electrons plus the 2 that it's grabbed from magnesium, and a 2 negative charge. Okay. Why do they react? Pretty simple, really. Metals have got low ionization energies. They don't have a very good hold on their electrons. They're prone to giving them up. Non-metals are the opposite. Very high electronegativities, really going to pull them in. Both of them are trying to get that full outer shell, which is normally a stable octet of 8. For the very first few elements, we're just looking for 2 in the outer shell. Basically, they want an electron configuration that mimics one of the noble gases, which is the most stable configuration. Okay? So to get that and make everyone happy, we transfer electrons from the metal over to the non-metal. Okay? So magnesium, when it gives up its electron configuration becomes the same as that of neon. Oxygen also becomes that of neon. Okay? Doesn't mean that they have become neon, because what defines an element is the number of protons in its nucleus, and that doesn't change. But the electron configuration has become the same as neon. Okay. Now, of course, some of them are going to be a little bit more complex, because you won't have a 1-to-1 ratio. So in this case, magnesium's giving up 2 electrons. Chlorine only wants 1 though. So you need 2 of them. Okay? So if you were drawing the dot cross diagram, you would draw chlorine out twice. They have shown all the electrons again, you don't have to. Okay, so you'd show them moving 1 to each of them, and then you'd show all of these happy little ions on the other side.